Welcome to Amber Skies, and yes, we are in a project, a lovely project. This is the, how can I put it, OBJ thingy. We're going to be reading OBJs, aren't we? It's a full 3D model exploration. And so far we have done some exploration. Yes, we've had an episode already, and look what we've got. We've got structures, lots of notes. And where was I up to? I had a to-do, didn't I? So we've got the vertex, texture, the normal, parameters, which I actually have never seen being used, but you never know, there might be some. And then we're into this faces thing, which I've actually, to do. Here we go. And coffee. Coffee. Yeah, I've got coffee. Right, let's get rid of this to do and let's get this set up and started. So I've got some new code here. I am not sure exactly how far down this goes. It goes down to there. There we go. Get rid of that. It's an overloaded function. Structure. So what I've got so far is this. Don't copy it down yet, because I'm about to alter it all. Int face number set to normal index. Right. I'm not sure I like that. I think we should make this up ourselves, because that then can become our index. Okay. You see, I've got this for VertexIndex. I've called it at faces. And yeah, it is, but it isn't. So if I was to say that that was VertexIndex instead, it would make more sense. Then we'd need the texture index. And then I wouldn't need these stupid notes. Every time I put notes in here, it means that I don't know what I'm doing, usually. Or I need reminding of what the heck I've done. So we'll get rid of that. And instead, what I'm going to do is I'm going to do one for each. So int m underscore, this will be texture index, because this is how it works. This is how it really works. We'll have 4 of them, please. And then we will have the normal index. Face number itself will be a generic number, won't it? Like a face number index. Okay, yeah, okay. I need to, you see, what you're doing here is you're creating your own language, which is why I'm thinking about it more than usual. Because I want everything to mean something. What this means, this gives the position. These numbers, these index numbers, give the position in, for example, the vertex structure. If we make a vertex structure like this line here, it will tell us, the vertex index will tell us where in this vertex structure to find the vertex. Yeah. And that will be good. This new code, by the way, is just subject to review. It's not in yet, so don't worry about that. That's just how am I going to be using, I'm just experimenting with how I'm going to be using these structures. So it's obviously a pushback and a vector and that kind of thing. And yeah, that would work. So yeah, that looks better to me for the faces, but it does complicate things, as you can see here. Because the face number is now the face index, isn't it? No, it's just the face number. And that will be the user's index number. So the user has to set that. I'm not happy with that because this so far has been all about pulling data off the hard drive, SSD, whatever you want to call it these days. And here I'm putting in a variable that's going to give us an index number. How's about we just take it out? Do we need it? Well, no, we don't. Okay then. Don't do things that make it complicated. And that's the answer. So instead of what I've got here, because remember it could be a quad, I'm keeping that, because if it is a quad you have to do it differently. Yeah. So what I'm going to do is I'm just going to delete the second one. Just a second. So just pop that out of reach for a second. Okay. And in the first one, I'm going to redo it. The first thing is obviously this is rubbish. So what we are going to have is int. So it's going to be vert1, comma, no, vert0. Do 0 first. So, and I can't call it vertex, can I? Yes. Yeah, it's not coming up with anything stupid. At least IntelliSense is seeming to work today. That's because I didn't add that to the project. So I clicked on that, add to the project, came in up here, and voila! IntelliSense started making its mess, which is always good. I like IntelliSense, it's silly. Very silly at times. Then we would have our texture. 0. This is how it's formatted. I'm doing it how it's formatted within structures. I want to take the structure that we've been given and just copy it into memory. So that's what we're doing. So it's texture and then it's normal. Yeah, we'll call it normal 0. And then you can guess what's coming up next. We need that to be repeated for each. Tab's not working. Okay. It'll work up to there. Oh, it'll only do it to that, will it? Oh, well, that's interesting. I'll have to reset that. I've got it. I've been going through all my settings and messing around. So, yeah, vertex 1, comma texture 1, comma normal 1, comma, and it still won't let me do it. Okay, that setting is going to annoy the hell out of me. Vertex 2, comma. So yeah, I'm just rewriting something that I had an idea on. I didn't like it. Yeah, well, happens a lot. Alright, that should do the first lot. Face number is no longer with us. Okay, that's looking better. And I've forgotten to put int in front of everything. Okay, fine. 'Cause I'm an idiot. This is how an idiot programs. Way! Keep programming until everything's been accepted by the system. That's it, that's better. Now that changes all of this. Yeah. How are we going to assign things? Should I? No, I can't. Okay, so, well, we can get rid of that. These lines are rubbish, obviously. But it's how you assign things, unfortunately. This one is quad is false. It's only got 3. So it's got 3 vertices, 3 texture coordinates, and 3 normals, all corresponding. So that's going to be good. That's going to be very helpful if we do it that way. So really, all we're doing is we are going to take something like VertexIndex, and we're going to say 0, and that's going to equal vertex 0, which is why I started it from 0. And we just copy that 3 times. Control C, is it? I don't know. No. Control X? No. Oh, I don't. Why does it keep doing that? What's wrong with it? Get out of whatever mode you're in and stop it. Goddamn thing. Right, just copy it over. I'm trying to get used to the keyboard, and it's so hard on this left hand that I'm just going to have to give up. I'm going to have to go with clickety clicks. Never mind. I don't have full control nowadays over it. So, anyway. That's what it should look like. And you can see what's going to come up next. We are going to do m_textureIndex. And I'm sorry, but that's bad. Alter it now. Starts with lowercase, please. And that's going to be 0 again, isn't it? I mean, I'm not bothered about how much typing or the size of the names or anything like that. That doesn't save memory. It doesn't make it any slower or quicker. But it needs to be able, you need to be able to read it in such a way that it matches all of these notes here. So when you look through these notes, like, and you got things like that one there, face 641, that will be face element 641. So it makes it understandable. It makes the code more understandable to what we're doing, or to anybody that reads it as well. So yeah, I don't know why I bother doing that. Why not I just do that? I should have had 2 spaces. Just click on that line, press V. There we go. It becomes 1, and that becomes 2. Yeah, so this is the largest structure so far that we've done, and it also is inherent with quad. This is where I was debating back in the vertex. In the last video I was debating whether to put the bool m is quad with the vertices, and the answer is no, you don't. I thought it all through and decided to put it here. I'm glad I left this one to be able to look at it and see what the heck I was doing. So now we're on NormalIndex, and that will just be 0 for a minute, and that's just going to be normal 0. All of these words that we're using for like vertex, texture and normal here are all only ever going to be used within this scope. So these aren't going to bleed over into anything else, so we can reuse names. So if you're wondering about naming conventions, it's all to do with these brackets. These brackets are called a scope, and at the end of the scope, anything that isn't held from outside the scope, like these are, vanishes, disappears, and goes goodbyes and nighty nights and all that lot. Very, very, very cute. So if I copy that line and just pop it in a couple of times, we're okay there. So that's 1 and 2. I actually did go through quite a lot of Visual Studio yesterday as well, just playing around with it, seeing what I could mess up. And I messed up a lot, like just doing numbers. And it was quite interesting. Quite interesting. So normal, yeah, we're okay there. And that's it. That's the first one. What we are going to do now is take that, copy the lot, and we're going to put it over here. And this one will be quad is true. So paste. So the first thing I'm going to alter is that to true. In other words, it does have 4. And all I'm going to do then is take a copy of you. And this is just going to be 3s. Oh, and it's redone. Yeah, it's doing what it's being told to this time. I can't argue with it because I've messed it up. I'm just going to leave it like that. I don't really care. So these are alright. But on each of these, we've just got to add one more. So it's VertexIndex, and it's 3 equals vertex 3. That one. And m_texture. What we're doing is we're overloading. Overloading in C++ means that you can construct something in 2 different ways. And if you're using C, you are now completely complaining at me that this won't work, because it won't. C++ is designed for this in mind. This kind of thing is like, oh yes, gorgeous. It means that you can have multiple declarations and multiple definitions of the same thing. In this case, we've got a triangle versus a quad. So it's quite sensible and it's quite understandable to what we're doing. Works nicely, but you can also do it, you can overdo it. Like on the vertex one, I could have done that as 2 different things, but that would have been overdoing it. There's no point if you've got one that's got equal to a default. This doesn't have equals to a default. So that's the big difference. That's normal 3. There we go. And that's it. That's the only modifications we had to do there. So we've now got a quad. And we've now got the definitions for a triangle and a quad. And we can do it all through this one struct. There we go. That'll do nicely. I'm going to save that out because that is good. I'm a lot happier with that than what I started with, because that is exactly what it says in the specification. The specification says that. So it says you can have multiple things do multiple things. So if you only have 1, 2, 3, for instance, for faces, you would come down here and you would have to put in 1, 0, 0. Because that's the smallest that you can do. I could make these equal to 0 and optional, which would be a good idea, because you need the vertex as a minimal. But I think it's going to be user preference on this. It's automated. We want to make it automated. Now, come on. Come on, blades. Settle down. Let's have some coffee and think about it. It's automated, so it doesn't know. If we read a face line, it could just be a list of faces. Face numbers. I might come back to that. I'll think about it. Might come back to it, yeah. Line element, blah blah blah, other geometry formats. Skinning, morphing, referencing materials list. Okay, we got to the materials list, haven't we? Features, universal, yeah. Do not support mesh hierarchies of any kind of animation. Yeah, okay, that's just referencing materials. Edit. Okay, did we get the materials? Oh, yes, we are getting the materials now. So this is the file name, not material name. It says it there, file name, so why have I called it material name? Yeah, it's because I'm an idiot. Let's change material to file. Well, let's tell ourselves exactly what this is. It might help if we tell ourselves properly what things are. You can see how things can get messed up if you're not careful. When videoing, it's quite easy to go too fast and not think about things, because you're always under this video pressure of the time spent doing things and trying to get across as much as possible in one video. That's the material name. So I've just called it name instead of material name. You see, coming back was a good idea. Material name. And this can now be material name. We can tell ourselves what things are. It's just that I haven't done it on here because I was rushing too much, I think, towards the end of that last one. I knew that I was running out of time. Okay, so that's those two altered. Go through things and alter the names. Again, here, object name. We've just called it name again, haven't we? Well, it isn't. It's object name. It's me being lazy. Control C. Okay. And this is now up. Control C. Control V. Yeah, it works. You see, if you read it. And this is group name. So I do apologise, I'm actually redoing things, but that's the way I work. I'll look at something and say, well, nah, doesn't quite read right. But now this is starting to make more sense to you, the viewer. It's not just me making things up on the spur of the moment. What you're supposed to do is follow what it says. And it's like a recipe. What I've done is I've downloaded the recipe for an OBJ structure, and this recipe I am now putting into memory so that we can use it. Right, object and group, yeah, I haven't started up at the top today and I should have done. So, starting up at the top, review. Vertex, looks good. Yeah, XYZ, W. Yes, I'm keeping that. The new code we're skipping for now. That's me just playing around off screen. Texture coordinate, absolutely, yeah. Okay, I'm happy with that. Vertex normals, yeah, that's normal. Vertex parameter, that's a parameter. Get rid of some space there. Don't really need that much space. Alright. And we'll put an extra space at the top there. Okay, just to face elements, we now know I'm more happy with because they can be designed in such different ways. And we've used an overloaded structure to be able to do quads. Line elements. Again, line element. Why am I abbreviating things? Never abbreviate. Unless you want to forget. See, I've got to come back to this in 2 years' time and use it. And this is going to be the best structured OBJ file you've ever known. We're literally going to have the OBJ file in memory. Well, not in our memory, but in the graphics GPU memory. Right, I'm a lot happier now. Because a lot of those things were bugging me, and I was thinking, oh, come on, Blades, you can do better than this. Don't shortchange your viewers. Give them everything. Right, so we're up to group main. We can start now, and we've only wasted 27 minutes fixing up with all the mess I've made. But we do now have the faces. So file format, right. Smooth shading. Okay. Relative and absolute indices edit. Oh God, no. Don't do that to me. I'm going to take smooth shading now. Because that looks good. There we go. What have we got here? S equals 1 or S equals off by smoothing groups. Okay. Does that mean we make it a string? It looks like it, doesn't it? Doesn't give us too much on this, unfortunately. It's, see if we've got any other information here about smooth shading. It's not something I'd use. We could just ignore this one. I know what it means, but do we need it? Yeah. Well, people will complain if I don't give it them, I suppose. Nothing here. It does actually affect things. Here we go, ambient, similar, KSNS, NS. Come on, we've got no shading. Ah, you see, it's not been done here, where I would have thought it would be. Ambient, on, off, nothing to do with shading at this point. It means you can have a choice of shaders for one object. One does smooth shading and one just does normal. Fong shading. It's called Fong lighting, really, it's not shading. There's an illum. No, it's not. You see, smooth shading would really be used with textures, I think. Or bump maps, or I don't know when to use them. But they haven't given us a lot of information. I'm going to store it, obviously. So we'll have a struct. It's called smooth shading. I'm getting used to this keyboard a bit better, aren't I? Good. And it's going to be an std string because of the way they've put it. And it's just going to be m_smooth shading. And that's just going to be smooth shading std string. And that's going to be smooth shading. And then it's just going to be colon. And then it's smooth equals smooth. Nice, that worked nicely. And we can finish that off with the brackets. I'm not doing anything in there. But now you can see what those brackets really are. I mean, why are we doing it this way is because it is the most flexible way of doing it. As you can see, the very, very simplest method to what is rather a complex method. You see, that's where the brackets aren't just placed at the end. And there's no colon, because you can't do it that way with arrays. You have to do it that way, unfortunately. Arrays are slightly different in C++. They can be awkward. You would have found out very quickly if you tried it. You would have just complained all over the place. Right, so that's smooth shading, which doesn't mean much to me. Okay. Right, relative and absolute indices. OBJ files, due to their list structure, are able to reference vertices, normals, etc. by either their absolute position, 1 represents the first defined vertex, n representing the nth defined vertex, or by their relative position, -1 represents the latest defined vertex. However, not all software supports the latter approach. Will we support it? Well, yes, automatically. Because of the way that I write. I use both at the same time, because all of my objects are created at the origin of the world, which means that they are all absolute positions and they are all relative positions to the to 0. So either of these will work automatically. All software supports, blah, 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 blah. And conversely, some software inherently writes only the last form due to the convenience of appending elements without needing to recalculate vertex offsets, etc., leading to occasional incompatibilities. What that means is build your object at the center of the world, and that should get rid of your compatibilities, I would have thought. But that's a nice thing to have in. So we're going to cut that section out. Where will we put it? Why they put it so far down, I don't know. Let's put it up here and see what we get. Let's begin with a hash. Yeah. Okay, I'm just gonna slide it in here and see what we want. Yes, can I help you? Yeah, okay. There we go, interruptions as well. Right, I'm just gonna put that as a subnote in there because we can. There we go. I'm not going to delete any of this information. You've already noticed that we are having all the information. Material template library. Yeah, we've got to keep that in. The MTL file format is a companion file to the OBJ. You usually get one, or should get one. Yeah, it's done by wavefront. ASCII text, just like the OBJ file. So we can read them with the same reader that we're already reading the OBJ file with. The MTL is still widely used, is outdated and does not fully support later technologies such as specular maps and parallax maps. Well, oh boo-ha. However, that does parallax maps, but never mind. However, due to the open and intuitive format, these can be easily added with a custom MTL file generator. Yeah, of course, you can add anything you want. You can actually develop your own file. More on that later. So that gives us that. And then we get the basic materials. Okay, MTL format defines a number of formats, 2 and 3. 2 and 3. Where's 2 and 3? Okay. Yeah, we are getting towards the end. Single MTL define multiple materials, define one after another, define material name colored, new material colored. So we're up to here. Yeah. Yikes. That's a big cut. And a big paste for so little. Well, if they're going to give us something, we're going to store it. That's the name of the game. The name of the game. Yeah. Thank you. Right, and here we go. I think we really start after this line here. Each starting with a new material command. Okay. So that's the first thing we should encounter, I guess. I don't know what this 2 and 3 refer to. But hey. Oh, it's off the wiki, isn't it? So it'll be something in the references section. So no, I'm not removing it. I'll add to it though. Yeah, thank you. Just remembered what it is. Okay, we've got a struct. Hey, you know what's coming up, don't you? Material named. Now, have we already done the material name? Smooth shading. Group name. Object name. We have. Under struct, use material. Okay, so you alter it. Is the answer. You have to do this. You've got to be careful. It says use material, so that's what we're altering it to. It's off screen. You've got to remember what you've done. Or things have to twig in your mind that something might conflict. And there was a possible conflict which I am avoiding right at the start. There aren't any bugs, there's only bad programming. And that would have been bad programming had I left it all to its own little devices to work it all out. So material name is a string. M_material name. You can see now how useful doing things this way is. It will stop conflicts. It will stop you at a later date making a big mess of your data. Trust me on that one. So material name. We've got to list all our structures out soon as well. That's going to be an interesting exercise. So material name, open brackets, yeah. And it's just going to be std string. You've seen this a million times now. And we just call it material. This is a convention that I use to make it very, very simple. You don't have to name things like this, but this is my naming convention, so I don't have to dream anything new up. Most people would have just put mat n or something, or mn. Why, when you can just type it out? That's my argument. You'll see me put I in for things. I'm going to stop doing that this time round, I think. Got something wrong here. That should have picked up. Okay. No. That's right. How do you spell material here? E. Yeah, E. I knew I got something wrong. And that's it. That's your function. Next. Right, new material, new MTL tells us that we have a material name, so we could got structure for it now. Excellent. What's next? Ambient color of the material is declared using KA color. Definitions are in RGB, where each channel's value is between 0 and 1, a percentage. So 0.1 is 10%. 0.5 is 50%, 0.01 is 1%, but you can also go up to 6 digits after the point. Think about it. So you could go 0.000325, things like that. Okay, it gives you millions of colours. So we'll have KA, KD, KS. That's your first ones. Will it just list these straight off, or do we have to take these separately? We have to take them separately. Okay. So ambient is this one. This is good. This is what we haven't used previously. And oh, does it make a difference? So let's pop it in here. Can I have some space, please? So this is structure. Ambient light, is it? What does it actually say it is? Ambient color of the material. In American, please. Reason why it's in American is again, conventions. If I remember to do everything in American, COLOR, then it makes it easier later on to match things up and to find them using the find function. So I use American. I learnt from Americans, unfortunately. The English weren't ready to teach. So it came out as an American colour. Lovely. We're not doing too badly on this today for once. So what is this going to be? It's going to be a float. And it's going to be a float of XYZ. No, it said RGB, didn't it? R G. It matters. P, because it looks better. And the cat's now sitting right in front of me, new telly. Okay, you can actually lie down there, Muppet. I can see the TV now. It's ace. Ah, I don't know. Okay, so we're going to use red, green and blue. So we don't have to keep memorising the order of red, green and blue. I'm going to put RGB to remind me. Everybody knows what RGB is, don't you? You don't need me to put red, green and blue in, do you? Well, we should, really. Shouldn't we? No abbreviations. I'm going to go through this and take out every single abbreviation afterwards. Just because I can. So, what we got? Ambient Color. And what we need are float, red, green, and blue. Oh, I have to put float in each time, don't I? Okay. And it's a colon, return. You don't need to return after the colon, by the way. You can keep going across the page, but I just find the line length gets a bit large. You know what I mean? A bit large. So M_red. God knows what I'm on. Am I on drugs? Yeah, I certainly am. M_RG green. Sorry, I'm having fun. I actually enjoy programming, yeah. Because when I'm doing it, it's just so funny. The things that you think of, the things that come up in your mind. Unbelievable. And that'll do, won't it? Does that look good? Red, green, blue to red, green, blue. We're only storing things, we're not doing anything with them. Oh, that looks good. That looks like ambient colour. We're going to have to keep doing these, so... Similarly, diffuse. A small little bit to put in here. I bet you never realised that you could program in English and then just copy it into C++. Well, that's how you should. You should always write the English first and then do the code. That's the best way of doing it. That way, you're programming in English, something you understand. You've got your notes being made, something you understand, and then you get your code, which is dead easy. What's this one? Diffuse color. Okay, yep, we're right with that. So let's pop this one in here. Can I have more screen? Thank you. Again, it's the same again. In fact, it's the same line. Yeah. And then it's just diffuse color, open brackets. RGB. Yep. And yeah, it's the same line. So mred equals red, green and blue. Exactly the same function, but with a different name. Anybody who is a C++ programmer out there knows where that's going. And if you're not a C++ programmer and you're looking in on this to find out how to do data structures, C++ allows us to use templates and things like that. So that a lot of the stuff in here will go into a template. And this will be rewritten into templates. But yeah, but that's not at this stage, it isn't. At this stage, everything you keep simple. Keep Keep it simple, stupid. Kiss your code. Yeah, that's okay. NS, so we'll copy that. They look as though they've got bored writing. And it's just getting shorter and shorter and shorter. Never mind. Okay. Right, it's the same code. I'm just getting bored of writing it now. Specular. So we are now on a Specular Color. There we go. Done. That's your Specular Color. That'll make it easier. Get some more spacing because I seem to be using it quite fast. Float. That'll give me space, thanks. Yeah, I only do that to split variables from a declaration definition, which that is both. Okay. We haven't even talked about declarations and definitions, have we? We're just doing a header file. Oh my god. This is the way you do it in C, to be honest with you. And then when we get to the C++ bit, it all changes. Oh wow, does it change? Right, what's next? Specular Color. I want to finish this today if possible. NS. Materials can be transparent. This is referred to as being dissolved. Unlike real transparency. Oh right, that's where you get transparency from. What is NS? Anybody know? You see, they've used an abbreviation. I've got no idea what NS stands for. So I'm going to look that up whilst we're there. All it's doing is giving us a one-liner NS. Hope it tells us somewhere what that is. Okay. Define one after another in the file, blah blah blah, new material command, yeah, okay. NS. N to me is normal. S. We haven't used an S anywhere. Could be saturation. Specular. Shininess. 0 and 1,000, and they put it to 10. I know what these are. These are the normal things I'd use. I'll have to look that up. I don't know what NS is. Not off the top of my head, but we've got one. So, yeah. Whoops. Let's just pop down here. It doesn't tell us what it is. Arf. So I don't know what to call it. Sorry. So it goes under the Blade's rule of thumb. Keep it simple. NS. I will discover that in my own time, and I will come back and I will make an amendment. If you know, you're probably screaming at the screen. If you do know, put it in the comments below and I'll alter that to whatever the correct name is. I think it's got something to do with reflections. The reflectivity of the colour. Shininess type thing. But that's a whole different kettle of fish when it comes to saying 10. No, that's a completely different thing. Okay, get back on track. NS, we're done NS, whatever it is. Okay, materials can be transparent. Some implementations use D, others use TR. Inverted TR equals 1 minus D, that's right. So TR and D are the same thing. Yeah. Oh, sugar. Dropped it. So, there we go. We only need one structure for that. Cut. And paste. There we go. So, how's this going to look? I want the 1 minus value. I want a TR, not a D. So transparency dissolved. It is 2 structures, isn't it? So we have dissolved equals transparency. So the first structure, I've got to choose one or the other. I don't like the word dissolved, so I'm going to go with transparent. Okay. Even if I can't spell it. There we go. That'll do for my structure. It's going to hold 1 float. Transparency. Yeah, that'll do. Because if somebody gets a D, we're going to have to program that in again. So if you get a D, it's going to have to be 1 minus D. It gets passed in. So I might leave a note here. No, I won't leave a note. It's the note's there. Oh God. Okay, transparent. Sorry. Because it's so close. Transparency. I think that's how you spell it. Yeah, right. No, we better keep it. My spelling is that bad that I've probably got it wrong. So you're laughing your heads off at me now. Because of the way I spelled my variable. Variable name, well, hey ho. And it's just a float. And that'll do. Colon, next line. M underscore transparency. Open brackets, transparency. There we go. Space, don't do anything. Right, I'm going to leave it to the user to get that right. Okay. That's okay, that's clear enough. The user can decide which one to use. Okay, I'll put transparency. Because that's what it is. Alright, okay, I'm happy with that. Multiple illumination modes are available per material. Oh god, these are enumerated as follows. That's what illumine means. 2. Highlight on. Reflection on. Rate. Alright. Well, I didn't know that. You see? That's what your notes should have in it. Not just NS. Bad notes versus good notes. You've got them right here. Oh, bless. Bless you, Wiki. Not everything in life is perfect. Me included. So all of this boils down to is an int called illumination. that's just going to be an int underscore illumination. And then we're going to have illumination. Ah, you've got this in the bag, haven't you? Illumination. That's okay. Colon m underscore I double L. Open brackets I double L. There we go. Done. So I've learnt something at the same time. I told you, every time I do one of these, I'm going to learn something. I didn't know about that. So that means you can, yeah, glass on 4. You can do glass. Oh, wow. That is awesome. Sorry. So in other words, if you want to program that glass into a shader, you can have a shader for glass. And if the illumination is 4, you can use correct shader for it. That is powerful. That is a good one to keep. Yeah, I like that one. Texture maps. Okay. Texture materials use the same properties as above and additionally define texture maps. Okay, so they're going to use new material, textured, yeah. We've already got that bit. We've got KD, D or TR. Illumination tool, we've got that. So we've got all the way up to there. And then we have all of this stuff to add. Okay, all these are .tgas. So this is just a name. But they're all different names. I see what they're doing. Okay. Options, that's up to the programmer. This is up to us. Okay. So we cut it there. And we come across and we pop it in. Never shy away from a challenge. Wow, this is a challenge. What I am tempted to do here, is do a string, an array of strings. But then, does it give them or doesn't it give them? Are these on or off? Are these the same or are these different? KA. Well, normally it's a diffuse map that's given for the general texture. The general texture is KD. Yeah, we're going to have to do them each separately for now. That's fine. I don't mind that. So it's going to be texture map KA. Ambient texture map. Okay. Got to just try and word it right. Forgotten to do something. That's why it was complaining at me. Okay, fine. So this is struct ambient. Don't put spaces in. Texture map. And that is going to be an std string. Standard string. Oh, by the way, to get standard string, you do have to remember to put string up there. hash include string. Otherwise, it won't work. It won't. It comes from the standard library for C++. And that's m_ambient texture map semicolon, and all we're going to do now is put out. It's obvious what we're doing. Don't worry about it. It's to start off with. This is the simplest way of doing it. It's just a lot of it. It's a lot of repetition. This is how you program, by repeating things, not by making things up. Ambient map. There we go. Lovely. And that will go to ambient texture map. Yep, that's lovely. That's done all right there. There we go. So we're going to have to do these for each one, aren't we? So it says there ambient texture maps. That's what we've called it. Right, okay, let's carry on with that kind of thing. Okay, so it's even telling us that most of the time these are going to be the same. Yeah, I know. But we can't assume that they are the same. Most of the time isn't good enough for us. Struct diffuse texture map. There we go. And again, it's std string. And it's diffuse texture map. Oh well. I should have just copied it over, you know. I mean, no, I shouldn't. Do it normally, it's okay. It's quicker actually. So you just type in diff. Make sure you get the right one. And that equals std colon string of that, because that should have an M in front. Why is it highlighting stuff when I don't want it to? Oh, stop it. Come on, will somebody please tell me what the hell is going on? What am I doing wrong with this silly text editor? Well, all I want to do is type M underscore, for God's sake. Never mind. And it's std. That Y's popped back again. It's not good, it means I'm getting tired. Diffuse texture. I mean, from here on, you could probably do the rest of this by yourselves. You don't need me to tell you what I'm going to type anymore. It's absolutely obvious what I'm going to be typing now. For the rest of these, there's no rocket science left, is there? It's just literally what I can do is I can. There's 1, 2, 3, 4, 5, 6, 7. There are 7 more structures there. And that's where we will start on our next adventure, because we have come to the end of our hour, and as you saw, my left hand is hurting. So thank you. Thank you for joining us. I will get through object data structure. Oh, I changed the name. OBJ data. I put data structure in there because it made more sense. So right click, rename, if you wish to keep it the same as mine, and that's it. In main, have I made any changes? Yeah, we've made lots. We are down to not much now, but we have to go through it all. We don't have a choice. If you want to do an OBJ file format, everybody will say, oh, it's the easiest format going. No, it isn't. It's ridiculous what it's got in it. Absolutely ridiculous. I mean, this part, oh my god, look at all these. Yeah, we have to somehow make sense of all of this lot. And so far, we've done a good job. We have done a good job. The structs are looking the same, which tells me templates are going to be coming in. But I was hoping this was going to happen, and I had a feeling it was going to happen, because when it comes to doing the programming side, it means that we are going to be able to just have one template to access a lot of these, and I mean a lot of these. So code, you would make a vector to store each set of whatever from the struct, to store each set or struct. Then you would have a function that would store the data, and a function that would delete all data to avoid memory leaks. And in between of those two, that gets expanded to push it onto the graphics card. I didn't go that far because I just wanted to have a look to see, well, just think through it a bit more. So that's what that's about, just me thinking through it. And there we go, that's today's episode. We will continue with this data structure business and probably finish it quite quickly now. Well, maybe not, because there's an awful lot to do. As you can tell, there is an awful lot to do. We're up to, what, 300 lines of structure. Okay, a lot of it's this, but, you know, it's always better to have the notes. Right, we are 1 hour and 12 minutes in. This is a close, so take care, everybody, and please have fun.